Manufacturing your product for mass production may seem intimidating, but it doesn't have to. The more you know about the process and the more informed you are, the better you can navigate those waters. My name's John Vogelman, and I run Avail Creative, a product design studio in Golden, Colorado. Here's 10 tips you need to make designing for manufacturing smoother. Tip number 1 is during the design phase, you want to simplify the geometry of all your parts. Your overall product should be as simple as it can be while maintaining the aesthetics and functionality you want it to have. Each part should be optimized for how it can be made in the simplest way that maintains the strength and other characteristics you want it to have. Every little bit of simplicity that you can integrate will make the product cheaper in the end and reduce costs for tooling, conversation time, and errors during the manufacturing process. Tip number 2 is what I'm calling scalability. You need to make sure that your parts that you're making one-off products for during the prototype phase can be made in higher volume batches that you'll need down the road. Whether this is 100 or 1,000,000 different products coming out of your manufacturing plants, you need to make sure that your design can work for those higher volumes. Certain parts can be made well in prototyping phases by 3D printers and can get you really quickly to that next step in the process, but are not feasible in mass production. They take too much time or cost too much money per part. So you'll have to consider that as you design the parts for mass production. Tip number 3 is to just pay close attention to the tolerances and fits needed in your assembly. This may sound obvious, but every little dimension and criteria that you specify for every part affects how the entire product will work in the end. You need to make sure that parts that are mated together have the correct amount of interference or the correct air gap separations between them. The more gap, for example, the more your product will shake and make noises. You're not going to like that. The tighter the fits get, though, they increase performance, but the costs can go up too because it's harder to dial in the exact tolerances for parts. Extremely tight tolerances on parts are going to increase the cost. The manufacturer has a built-in system and way of quoting, and they know what the standards are for that fabrication process in terms of tolerances. If you ask for a tighter tolerance than what is the standard, they'll charge you for it. Tip number 4 is material selection. This is obvious. Every part in your final assembly needs to have its own material specified for it. Sometimes this gets overlooked though. For example, if you have metal hardware like screws or nuts involved with your assembly, you might just say, I want this to be metal and strong, and tell your manufacturing plant that. When they hear that, they're going to try to increase their profit margin by going with the cheapest metal that they can get away with at that point. But then they might introduce some low-quality steel, it gets rusted, it ruins your product in mass production or when it hits the market. So you want to tell the manufacturer exactly what material every part has to be. There are hundreds of plastics, hundreds of alloys of metals, and you have to work with your designer or with other experts in material selection to determine what the best material is for your use case. Cost comes into play here, just as it does with every other consideration I'm listing today. There might be a material that is just slightly better than a different material, but it costs twice as much. That's a real thing that happens fairly frequently, and you'll have to decide whether that small amount of performance benefit you get is worth the profit margin loss. Tip number 5 is to consider the assembly process. Now, this often gets overlooked by most designers, including engineers. It's kind of a specialty and seen as a luxury item to spend your finite resources stressing about how it might be assembled. The production staff that is in the manufacturing plants that has to put all these pieces together to make your product, they have to do that either by hand or with machines. So they have to figure out how it goes together. The easier it can go together, the less time it takes them to deal with the assembly, which means lower labor costs that they will forward on to you, the project owner. This also plays into whether you want the product to be serviceable or maintainable down the road. If you want your end user that is buying the product to be able to take the whole thing apart, fix little pieces inside, put it back together, and keep using it, you have to think about that during the design phase. Tip number 6 is to determine the correct or ideal fabrication process for each part involved in your assembly. You're going to have a lot of parts involved with your assembly, and some of them might not need to be fabricated at all. You might buy some off the shelf. That's called stock purchasing. Whether you buy it and give it to your assembly team, or the manufacturer buys it from their own supplier and uses it during assembly, those can be sourced separately from what is custom fabricated for you. Fabrication is just anytime anything is being made for you out of a raw material. You are going to have to choose what kind of process to make each part in, because if you don't, the manufacturer will choose for you, and there are drawbacks to certain ways of making something versus other ways. Sometimes it's purely a cost difference. Sometimes it's lead time. It might add a few extra weeks to get your products in hand from the time you place the order. Sometimes there are little design aspects of the parts that are visible by eye when certain processes are used, but not when others are used. Tip number 7 is to adjust your 3D models after you've selected what kind of fabrication method each part will be made from. Oftentimes, to get through prototypes quickly and learn and iterate, it is normal and good to do that as fast as possible, which means designing the parts in such a way that you can evolve that prototype to the next level. But once you start to get closer to your final prototype and closer to production, you need to start considering how the parts will be made. Once that is chosen, each part needs to go back into the 3D model and be changed so that it can be made in such a way that you've selected. For example, plastic injection molding is a very common, maybe the most common way of making parts nowadays for consumer goods. There's a lot of special rules related to how those parts have to be designed. For example, you have to have constant wall thickness on a majority of your part in order to ensure a proper flow of that molten plastic through the mold. This is so that it ends up looking and feeling the way you want it to without breaking on you. It also has to have draft angles so that it can release from the mold without breaking the part or the mold when the mold comes apart for each part. There's just so many little details here. This is where it really comes in handy to use a professional designer or expert to help guide you through that process. Tip number 8 is to have what is called a bill of materials report. That is effectively just a list of every part involved in your assembly and all the important criteria related to that part. This will be super handy for the manufacturing facilities and your supply chain to have in hand, and will provide a point of reference so that when you're on the phone with them troubleshooting issues, you can say, refer to this part of the document. This is where I specified the criteria that you need to pay attention to. Some of that criteria is the name and description of the part, the approved material, texture, finish type, and sometimes fabrication process, as well as whatever other details you want to include on this report. Sometimes I like to have a column just for general notes where if there's a certain part that has a special criteria or I want them to pay attention to something, for example, make sure you don't punch this hole too close to the edge or you'll break through the edge, I'll write it in a general notes section. This is up to you how you structure your bill of materials, but the cleaner and more organized it is, the easier it is for everyone to understand what's going on. Tip number 9. This is to specify what you want the quality assurance or quality control requirements to be for making the parts. Typically, the way that you do this is by creating a quality assurance or quality control report document that has sign-offs. The first place this comes into play is during your part fabrication. If you have custom parts made, someone needs to look at it and inspect it for the criteria that you tell them to look for. This might be cross-checking your technical spec sheet drawings for every single dimension, or it might be a more casual visual check just to visually compare quickly between the parts. That's the first step. Another place you can integrate quality control is for your sub-assemblies. You can imagine your overall product, if it's made up of multiple parts, being your full assembly final product. But oftentimes within those products, there are smaller assemblies within them. For example, a power control box might have an internal cluster of electronics that would be its own subassembly. You might want to get that subassembly tested and inspected on its own before it gets put into the larger assembly. That's so that errors can be caught earlier in the process, and in the end, you don't have to find out there's something wrong and not be sure which aspect of your overall product is broken or not working right. The final place I would recommend getting a quality control check done is for your final assembly before it gets wrapped in its final packaging. You know, most assemblies get put into a box and then they'll go to a warehouse getting ready for distribution. Before they get put in that packaging, someone needs to look at a certain percentage of the overall assembled units made to check them for everything they need to look for. This can be super superficial and just a quick inspection that's visual. Those are cheap and easy to do and pretty standard. Or they can be very thorough, where let's say 1 out of every 10 units is taken off the shelf and tested for every bit of functionality that it needs to have. You can imagine an airplane needs every single airplane to be fully inspected before it goes onto the market. But something less important, like a pair of tennis shoes, might need 1 out of every 10,000 pulled off the line to be fully inspected. You will decide this criteria and negotiate it with your manufacturer. Just like everything else, they will charge you the more intense the quality control checks have to be, and the more sign-offs there are, present more possible liability concerns for them, so they will also charge you for that reason. Tip number 10 is a big one. It is selecting your supply chain correctly and then figuring out who is going to manage that communication between you and the supply chain. You'll have to think about whether your product is made domestically or internationally. There are different pros and cons to both ways of doing it. It might be a hybrid model where some parts are sourced internationally, some are fabricated domestically, and then it gets assembled domestically as well. There's all different ways that you can set up your supply chain, but you will have to pick suppliers that are vetted, that you can trust. Don't go just on cost. Sometimes quality and reputation are important too. You need to ensure someone on your team has good communication skills so that they can handle the supply chain management aspect of getting your first batch made. There's always going to be some disagreements back and forth between the supply chain and the part owner or the designers, so they need to be able to overcome those obstacles in a professional way and compromise when needed, and don't compromise when you need to stick to your guns on a certain aspect of the design. This person should be experienced in talking to people of all different backgrounds. So whether they're talking to an upper management or manufacturing plant owner, for example, or if you're talking to a production technician, you need to be able to convey to them what they need to do to make that exact part the way you want it to be made. The better the manufacturing plant is that you source for your supply chain, the less issues you should have with communication, and the more they should take this on themselves rather than it just being on your shoulders to deal with. As you can tell, there's a lot to think about when designing a product for mass production. But as long as you have attention to detail and communicate clearly with your supply chain, you can overcome all the obstacles along the way. And of course, if you have any more questions or an idea for a product, feel free to reach out to us at availcreative.com. We're happy to help.